Question 5. We've got two parametric equations, and we're suggesting that they're actually going to be the same. So let's have a look. So let's rearrange this one. So I'm going to do x take away 1 divided by 2. And let's put this into here. So I've got 3 lots of x take away 1 divided by 2. Let's put all of this in one fraction. So I've got 4 plus 3x minus 3 over 2. And so what's that? That's 3 over 2x from here, 3 over 2x, and then I've got plus a half. So that's the straight line, and we've got a small part of it. We've got a small part of it here to here. The bit that we've got is going from 2 to 5. And so what are the x values we're going from? We're going from the x value 5 all the way up to the x value 11. And the y values we're going for are going from 3 times 2, 6, add 2 makes 8, all the way up to, stick the 5 in there, 17. So we're going from 5, 8 to 11, 17. So we can do some Pythagoras to work out the length of that line. So the length of that line is going to be the square root of here to here is 6, plus here to here is 9. So the square root of 6 squared and 9 squared, which I've got the square root of 117. My calculator's doing my surds for me as well. So I've got 3 root 13 for the length of that part of the line segment. Notice there's some terminology here, isn't there? That this is a line, and this is a line that lines continue on forever. But this is a line segment because we've only got one little part of it. Right, so now we're going to do the other part. And with the fractions, this is going to be a bit more interesting, isn't it? So we've got x is equal to this. And notice that y is equal to t over this. So I'm going to be a bit clever here and say that this is the same as t times by 1 over 2t take away 3. And I'm doing that because I've already spotted that this is what x is. I'm going to put times x there. So now all I'm going to do is rearrange this to get that t there. So if I flip them both, and then I'm going to add the 3 and divide by 2. So I've got that. So what have I got? I've got y equals times by x. And this will tidy up. See, look, x times 3 over 2 gives 3 over 2x. And x times 1 over 2x makes a half. And that is exactly the same as we had up there originally. And continuing with the Pythagoras part of it as well. So the t values were between 2 and 3. So stick the 2 into that, and we're getting 1. And stick the 3 into that, and we're getting 1/3. And notice it is the other way round there, isn't it? So, and the y values, stick the 2 in here, we get 2 over 1, which is 2. And stick the 3 in here, we get 3 over 6. We get 3 over 3, which is 1. So we're going from 1/3 1 all the way up to 1, 2. So Pythagorasing that, there to there is 2/3, plus there to there is 1. Oh, you can't see it. So 2/3 squared, add 1 squared. So I'm getting the square root of 13 over 3. Square root of 13 over 3.